welcome, welcome to your asynchronous lesson for today. Now you're first going to start off by finishing your food for your perfect protein spreadsheet. Now I believe we need to work on variation, greenhouse gas, liters of water, and eutrophication, so I'm going to quickly cover those 5 concepts. So when we talk about the variability of proteins, we're going to be looking at, let me find it, this graph right here. How does the carbon footprint of protein-rich foods compare? And what you will see is that different foods have different ranges where different types of farms for beef or for lamb or fish or cheese have different levels of CO2 emissions. So we can see this as a range of 0 greenhouse gases per 100 grams of protein all the way up to 30 grams of CO2, or 30 kilograms, of carbon dioxide per 100 grams of protein. And what you really want to think about is what is the range or variability of your protein's environmental impact. So for example, beef environmental impacts can range all the way from 30 kilograms per 100 grams of protein all the way down to 3 or 4. So the range is roughly 26 kilograms of CO2 depending on different practices or whether the beef is dairy or grain-fed. So you can put in this right here, the variability as a number. So I'm going to go find sheep. Believe this is sheep. And greenhouse gases is between 10 and 30. So I'd put 20. Just citing the range. You are then going to go and take a look at how much greenhouse gases are emitted per 100 grams of protein for your food item, which is down here. So greenhouse gases per 100 grams, I emit 19.85 on average. So I would put 19.85 here. I'm going to find how many liters of water are used to make 100 grams of protein. So sheep, 901 liters. It's about 350 gallons worth of water for 100 grams of protein from sheep. And then eutrophication, which has everything to do with pollution of nutrients. So I'm going to find eutrophication emissions per 100 grams of protein, and sheep emit 48.5 grams of pollution for every 100 grams of sheep protein made. Now this is going to be giving me some analysis in terms of grams of phosphate. So I need identically 1.4 grams of phosphate to make 1 gram of protein. I need 9 liters of water for 1 gram of protein. That's 4.5 bottles of Pepsi. And I emit 198 grams of CO2 per gram of protein, so 1 to 200-fold increase. So once we have all of our perfect protein data input, we are going to be working on this assignment right here called the perfect protein, which is going to be a data analysis document. Now you're going to be answering 4 questions where you're going to be citing specific numbers and units, using that data to justify specific policy or opinion concepts, and you're going to be using claims of proteins' pros and cons that are based in evidence. So you have 4 questions that you're going to be doing by picking 3 protein sources. So the first part is you're going to look through this completed sheet and think about, oh, did I get rid of it? Rats. Sorry about that. You're going to look through the first completed section and you're going to think about, which of these 3 proteins do I think are best for humans? You can be thinking about this based on calories, fat, sat fat, protein, iron, and you should also be justifying your answers by thinking about the Jamboard, Human Nutrition 101. You're then going to, using the second component of our spreadsheet, compare and contrast the environmental benefits and consequences of your protein choices. So you're going to be really thinking about why might my protein choices be good or bad depending on a variety of environmental impacts, which you can get all the way from land use to eutrophication. The third question is going to be having you look at each climate has its own climate risk. And this is a New York Times article that we'll spend more time looking at throughout the year that looked at every county in the United States, and they assessed whether that county would have a high water stress, heat stress, extreme rainfall, wildfire, hurricane, or sea level rise. So the question you have for the third question is you're going to pick a place that you might consider home, and you're going to use the second section of the environmental impact and this map to think about why the local agriculture of your region should only produce 1 out of 3 protein sources, given the changes that you might see in your climate, as well as harmful environmental impacts. So for example, if I click Vermont, Vermont is supposed to get lots of rainfall. So I might pick a protein source that needs a lot of water because I am not going to be worried about water scarcity. The same time in California, I might be really conscientious about water heavy proteins given that water stress is going to be very high in terms of a risk. And then your fourth question is going to be thinking about possible solutions. So you're going to be looking at the second part of how does agriculture change our climate, which you can find here. And you're going to be taking a look at the second part, which is all about solutions or ways that we can prevent larger impacts on the climate, as well as this article called Change Your Diet, Change Your Destiny, which is going to be looking at the environmental scope of different diets and different foods based on calories and different types of protein. And I want you to cite specific examples of how and why your 3 different protein sources might either need to be reduced in consumption or its management or production shifted and transformed based on these 2 articles. At the end, I want you to state which of your 3 proteins are most likely to be the perfect protein and why. On class in Thursday, we have a free period, so if you need time to wrap this up or finish it or get help from me with any of these questions, feel free to start this and submit it in class on Thursday. I hope you have a great day, and I will see you on Thursday.